here Seth Shostak from the SETI Institute. I think he runs one of the places that I love best in California, the other one being the JPL Mission Control Room for deep space missions. And he runs the place where they collect all the signals, and we may find about those from his talk. So give him a hand now, and I'll cut short.
Thank you, Boris. I'm sure that's the last time you'll applaud. By the way, I don't want you to think that the fact that my laptop does not interface with your system means anything with regard to the kind of signal processing that we might have to do to find aliens. I mean, there's no reflection on that. The other thing I might say is that I do not run the SETI Institute, although I would like to think that I did, but I am not the boss there. I am merely one of the worker bees. I'm an astronomer. Anyhow, what I'm going to talk to you guys about today, and also I hope to entertain your questions on this subject, is why we think the aliens might be out there, how we're looking for them, and what it would mean to you, the car buyer, if we were to find them. So, and then I'll try and leave 5 minutes at the end for questions, because I know you'll want to grill me like a cheese sandwich. To ask all those questions, you know, I'm deliberately avoiding addressing, like, why are they invading Milpitas, which Boris tells me they are. I'd first like to ask, how many of you think that the aliens might actually be out there? How many of you think that there could be some cosmic coming? Yeah, well, there's almost no point in giving this talk, since you already believe this anyhow. How many of you think, no, probably not? Okay, I want to talk to you guys later. All right, can you still hear me if I wander around? Because I thought I'd just sort of wander downstairs and out the building. Well, if you were to grab the next 10 astronomers off the streets of Mountain View, not necessarily a good idea, but if you were to do that and ask them, do they think that the aliens are out there, I suspect most of them would say yes. Not because we found them, but simply because there's a lot of cosmic real estate. As you know, this is one of the Hubble Deep Field photos, and you can see here a lot of stuff. It's mostly galaxies, actually. There are a couple of stars in this photo. Now, there's a nearby star, and there's another one up there. You can tell from the diffraction spikes. But everything else in this photo, which, by the way, is a very small part of the sky. This is the part of the sky that you would cover up with a pinhead held up here. Okay, so it's a tiny bit of the sky, but everything else you see in this photo is a galaxy, like the Milky Way, right? And a galaxy typically has a few 100 billion stars. So there are a couple of 100 billion stars, and there are a couple of 100 billion stars, and another couple 100 billion stars. And in fact, every dot here, these little dots, they're all galaxies too, right? It's just that they're farther away. Now, you can see here on the order of maybe 1,000 galaxies. If you were to take photos like this all across the sky, something for which your tax dollars are insufficient, but if you were to do that, you would count up about 100 billion galaxies. So now you got the picture. 100 billion galaxies, each with, say, 100 billion stars. That's what, 10 to the 22 stars in the visible universe, which, by the way, might be a tiny fraction of the actual universe. So 10 to the 22, that's more than, I figure, more than all the grains of sand on all the beaches of California. That's a lot of stars. And so for the 4 or 5 of you guys who think, you know, this is the only grain of sand where anything interesting is happening, I have to say that that's a certain audacity that might serve you well here in Google, but nonetheless, it is a very audacious point of view. So, you know, we figure, you know, with all this real estate, it would be strange if we were the only game in town. All right. So how can we find extraterrestrial life, and when are we going to do it? Because the bottom line is, and you may not know this, but the bottom line is that so far we haven't found as much as a microbe, even a dead microbe, from any other world, right? You know, it's been 12 years ago now, 13 years ago, it's 12 years ago, when there was this big story about the Martian meteorite. Actually, it was 1996, so 11 years ago. Biggest science news story of the year was this dead microbe from Mars found in a rock that was picked up in Antarctica that had come from Mars, right? We know it came from Mars because on the bottom of the meteorite there was a bronze plaque that said made on Mars. We know it came from Mars. That's not controversial. What was controversial was whether what was found inside was actually a dead Martian. And the usual assumption is it was not, actually. Most of the experts in the field find that very contentious, that evidence. So we don't know of any life beyond Earth. Right? But I suspect that in the next 20 years, we're going to learn differently, because there are 3 horses in the race to find life beyond Earth. And I think that each of these horses has sort of an equal chance of winning. For example, we might find it nearby. All right, we might find it on the planets that are not too far away from us, like Mars, or maybe one of the moons of Jupiter. We might sniff it out. We're trying to build telescopes that could examine the atmospheres of other planets and maybe find some telltale ingredients in those atmospheres that would tell you, hey, you know, there's some biology on that planet. And then, of course, we might find the intelligent variety of life. I'll tell you what intelligence means later, and you can judge whether your coworkers qualify. Okay, now, as I say, each of these three approaches is being pursued, and each of them, in my view, has kind of an equal chance of succeeding in the next 20 years. Okay? I might point out, these are mostly being done by NASA, and of course, NASA's looking for stupid life. We here in Mountain View, we look for the intelligent variety. Okay, so how are they doing it? Well, just very quickly, I mean, looking for life nearby. That's all dead obvious. I won't go into this story. You've heard it before. You'll probably hear it again. We can go to Mars, but not just Mars. Mars probably has liquid water if you just drill a hole 100 feet deep or a couple of 100 feet deep through the surface. But, you know, there are 6 other worlds besides Mars and the Earth in our solar system that show some evidence for liquid water. Right? So 7 in our solar system. Now, maybe all the rest are sterile, but there are at least 3 moons of Jupiter that probably have more water each than the Atlantic and Pacific put together. That water's been sitting there for 4 billion years, and maybe there's just nothing in it, but maybe there is something in it. Okay? So that's one possibility. And we're going to go to Mars. In the next 20 years, we may get the money to actually bring rocks from Mars back to Earth where you can really examine them carefully, and maybe we'll find life on Mars. I think the chances of this happening are pretty good. Okay, so that's one horse. The other horse is to sniff it out. To do that, you have to build these big telescopes, big phalanxes of mirrors, fly them into space, actually fly them beyond Jupiter where there's less dust, because these things work in the infrared. And they might be able to see planets around other stars. Now, this little cut up here shows you what a star with a planet looks like to our biggest telescopes on Earth. You don't see the planet. The reason you don't see the planet is because it's buried in the glare of that star, and it's very hard to get rid of that glare. That's an optical problem, okay? But if you have an interferometer, a bunch of antennas in space, then you might get a picture like this, okay? So there you see the planet, and if you can see it, if you get a pixel worth of planet light, then you can pass that light through a spectrograph and perhaps make a very crude analysis. Here's a very crude spectrogram that might tell you, hey, there's some oxygen in that atmosphere, or maybe some methane, or carbon dioxide, or water vapor. And you know, the reason that there's all this oxygen in the air, well, less all the time, but the reason there's all this oxygen in the air is because of the work of bacteria, cyanobacteria. They breathe in carbon dioxide, they exhale oxygen. That's where it all came from. Okay, so if you were to find oxygen in somebody's atmosphere, you'd say, hey, you know, they at least have bacteria. Might not really be a party planet, but there's life there, okay? All right, time scale for doing this, well, there's some dates up there, but you can forget all those because the current NASA administrators put everything on hold for lack of money. Yeah? Does this anticipate finding planets smaller than gas giants? I'm glad you asked that question. I was actually going to say hold all questions to the end, but let me just say that because there's a story, a science story, that'll break tonight. The embargo runs out at 7 o'clock. That the European astronomers have found a planet around a star with the sexy name Gliese 571. Is that it? It was 851. I can remember 581, I think. Gliese 581. You can find this on the web already because, of course, in Southeast Asia, they haven't been listening to the embargo. But in any case, this planet is around a dwarf star. It's very close to the star, but the star, on the other hand, is fairly dim. So the average temperatures on this planet are about the same as you would find in Fremont, which is considered suitable for life, okay? And the really important point is that this planet is small. It's about 50% greater diameter than the Earth. Okay, so it would take an extra 50% of flying time to go around it, but that's not so much. So it's probably a rocky planet. It could have liquid oceans on the surface. This is the best candidate for life we've found beyond Earth. It's suggesting that planets the same size as Earth might be very common. In fact, if you're interested in this, I'm going to be talking about it on the radio tonight if any of you listen to Coast to Coast AM from 10 o'clock tonight on White Sheet Radio. Okay, that's scheme number 2. And this has also got a time scale of on the order of a few decades. And I think there's a good chance this might succeed. And the third way to find it, and what I'm going to talk about here in the remainder of this soporific presentation, is to find life left by intelligent beings. Now, what would be the evidence for intelligent life? I mean, you might, obviously I'm going to talk about how you might overhear transmissions, but there are other ways to find it. Maybe they built something you could find, right? Maybe they're artifacts. For example, this is one of the photos from the Apollo missions that NASA never released because they figured you wouldn't be interested. But clearly, if you were to find something like this, you would say, hey, doggone it, Bob, that doesn't look so natural to me, right? Now, we haven't actually dug up the moon looking for these sorts of things, because again, there's no money. And in fact, we haven't even dug up the Earth looking for this, although we have dug up parts of West Virginia. But it turns out that coal miners are not terribly schooled in alien artifacts, so they probably just throw them away. But this is a legitimate thing to do, to look for artifacts. Maybe not nearby. Maybe we could find ring worlds or Dyson spheres or some of these other sort of gargantuan projects that advanced aliens have built. After all, the Earth is 4.5 billion years old, but the universe, well, the galaxy, is 3 times that old. Okay, so there's been plenty of time for them to do this if anybody out there wants to do it. You guys have all these solar cells out here. Well, maybe they've sort of encircled their entire star with solar cells, which gives them a lot more energy for their gusto-grabbing lifestyle. And we might be able to find that from the waste infrared radiation that would emit. There have been some searches for this, but we haven't found them so far. But it's a legitimate approach. Another way to look for them is to, maybe they're flashing lights at us. Remember the old cowboy movies? They would use their shaving mirrors. These cowboys always had shaving mirrors. They would kind of amaze me. But they'd use these shaving mirrors to warn you, the other cowboys that the Indians were coming over the ridge or whatever. Well, that makes sense. We never used to do this because of considerations about the energy cost of sending things on light beams, but it turns out it's a very practical way to signal. And in fact, this is over in Lafayette on the East Bay, but there are at least 3 experiments now at Berkeley and Lick Observatory, just down here in San Jose, and then Harvard and Princeton have one, to look for flashing lights from the sky. And the way they do this is they just use these ordinary telescopes. These are kind of 1-meter mirror telescopes, not useful terribly for astronomy, so you can use them for this. And you just put some detectors on the back of them. They're really just, that's the Harvard one, photomultiplier tubes. This is the way it works. Light comes in from the telescope and it goes to a photomultiplier tube. In fact, it goes to 2 photomultiplier tubes. In fact, it actually goes to 3 photomultiplier tubes. That way, you look for a coincidence in the events in these 3 tubes, and you can be sure that that's due to something coming in the telescope and not due to radioactive decay events in the photomultiplier tube or noise or anything like that. Anyhow, all you do is you just look for brief flashes of light. And it turns out that makes sense because if you were to take the biggest lasers we have, which are over in Livermore, right, used for fusion experiments, you flash those things for 1/1000th of a second, and they're really bright, right? They've got like 10 to the 12 joules or something for 1/1000th of a second. Right? Now, you aim that flash into a mirror this big, and you aim that mirror at a star system 100 light years away, and just do the calculation. It's one-line calculation. It turns out that flash will outshine our sun, right, at the distance of, say, 100 light years by a factor of 100 or 1,000. In other words, we can build lasers. 50 years after inventing the laser, we can build lasers that can outshine the sun for 1/1000th of a second with a mirror, okay? So if we can do that, they can do it, so we should look for these things, which we do. This is, of course, Lick Observatory taken from an airplane flying out of San Jose, and this is the setup they have there. It's in this white box here. It's a very simple thing to build. We ought to have a lot more of these things. It's like $5,000 or $10,000 worth of parts put together, in this case, by this undergraduate here. So it can be done. Well, she's not an undergraduate anymore. She just retired. Okay, now the other way to do it is to do what Jodie Foster did. Anybody see this movie? Yeah, okay. So there's Jodie sitting down at the VLA in New Mexico, which, by the way, has never been used for SETI, but it's photogenic. And as is, I suppose, Matthew McConaughey here, who doesn't actually do anything in the film, but whenever you say that in mixed company, the women all say, doesn't matter. But okay. Anyhow, this is all based on the SETI Institute's work. This is a Mountain View story, in fact. In fact, we were even consultants for the film, which leads to lots of good stories I'll tell you over a beer sometime. This is one of the antennas that was used in contact. This is just a crenellated topography of lovely Puerto Rico here. And you see this thing here. That's the Arecibo telescope down in Puerto Rico. Anybody been to this thing? Nobody? Next time you go to San Juan, next time Google sends you to San Juan for reasons that are obscure, make sure you rent a car. It takes 1 hour and 15 minutes to drive up to this thing and take a look at it. This is what it looks like from the ground. It's 1,000 feet across, which makes it the world's biggest antenna. In fact, I figure it'll hold about 4 billion scoops of Baskin-Robbins, but not a good idea in the tropics. This thing can see about 1/3 of the sky because the Earth rotates and the receiver can be moved around a little bit. And this is just one more example where bigger really is better because it's very, very sensitive. The only trouble with using this telescope to try and find ET is that this telescope is in heavy demand. by people studying galaxies, quasars, and things, not quasars, galaxies and pulsars mostly. Okay, so we've used that, but we'd have to build special receivers. Now here are some of the receivers we use because we don't know exactly where on the dial ET might be broadcasting, right? We never got an email, hey, I'll be at 1547 megahertz on the dial. You don't know. So we have to cover as much of the dial as we can. So we've got these PC-based receivers. Each one of these has 2 million channels, each about 1 hertz wide. So that 2, 4, 6, that's 8 million channels. We got lots of these boxes. These are a couple of our engineers, and as you can see, they're proud and happy about having designed these things. Now, how do you know? I mean, all right, so you turn all this equipment, you point it at a nearby star. How do you know if you've heard anything? Well, that was easy enough for Jodie Foster. I mean, she just put on a pair of earphones. She sat on the hood of her car for about 20 seconds, and then she heard something that sounded like somebody shoved a grand piano out of a 10-story window. Well, it doesn't happen like this, of course. In fact, we told Warner Brothers, they said, this is wrong. As if that was news to them. This is wrong because we're monitoring 56 million channels at once, so you have to put 28 million pairs of earphones on Jodie. And they demurred. They said, look, we're not going to do it. It'll crowd the shot. Mess up her coffee. So they didn't do that. This is what it really looks like, of course. This was down in Puerto Rico, and there are just a couple of workstations here, right? And they're listening to all, in this case, 56 million channels once a second, okay? And they don't get tired. They don't go for coffee breaks. And in fact, that carbon-based life form sitting there wouldn't actually even have to sit there if all this were reliable. It's not reliable, unfortunately. It's a one-off system. So you occasionally have to reboot it or fix things or whatever. But most of the time, you're just sitting there taking self-portraits, as this photo here. Okay, so that's how it really works. Now, what are we looking for? People think, yeah, okay, so you're looking for the value of pi or maybe the Fibonacci series, if you're a Dan Brown fan or whatever. Well, that would be very disappointing. I mean, I learned the value of pi in the 7th grade. If you finally hear the aliens and they tell you something you learned in the 7th grade, that we don't care what the message is. In fact, we don't even have the capability in most instances to find the message. We're looking for narrowband components in the signal, what the radio amateurs here would call carrier waves. And in fact, this is just a picture I took off the screen in Puerto Rico, and you can see these narrowband signals right here. Those are the marks of a transmitter. Nature does not make signals like that. Okay, so it looks pretty good. They're the Klingons and whatever. But they're not. Those are all, yes, they're all transmitters, but they're all terrestrial transmitters. Right? They're mostly communications satellites wheeling overhead or the radar down at the local air base or whatever. Okay, and you have to get rid of all that stuff. It's very, very difficult. Okay, that's a big problem. Okay, just for those who care about the numbers, let me just show you how much of the sky we've actually looked at. Occasionally you'll read in the popular literature, well, these SETI guys, they've been busy at this for a long time, and they still haven't found anything. And maybe Shostak, well, they never named me, but one of my colleagues, I'll spare them the embarrassment, ought to throw in the proverbial bath linen because, after all, they've been doing this so long and they still haven't found anything. But the answer is we've actually barely scratched the surface. The number of star systems we've looked at carefully is like 750, right, out of a galaxy of a couple hundred billion stars. Right? So it's very, very early days to get discouraged, except that you might say, but it's taken you decades just to do 750 stars. Isn't this going to be too long a project for you? It'll take a few millennia at that rate, and that's true, but I'll get back to that. Now, there are a lot of ways we could improve this search, of course. I like to consider the problem from ET's point of view. Here's a photo of the galaxy made by a space probe that you never heard about. And it could be that ET's just trying to get in touch with us because they know we're here and they find something interesting about us. Right? Although if you listen to late night radio, they'll tell you the aliens haven't gotten in touch because we're ruining the environment and all these sorts of things, as if they care, right? I mean, it's sort of like saying that E.O. Wilson isn't going to study ants because they get into wars with other ants. I mean, it doesn't make any sense. But they could be responding because they know we're here. But the trouble is, these are the people that know we're here, right? That pixel there. Nobody knows we're here. Right? We've been broadcasting into space for what, 50, 60 years? Right, so those early episodes of I Love Lucy or Kukla, Fran, and Ollie or whatever, they're about 60 light years out. Okay. Now, within 60 light years, you can work this out. Within 60 light years, there may be a few thousand stars, no more. And so the chances that there's an ET, that there's an advanced society within the nearest couple of thousand stars, I think are pretty slim. So I think it's safe to say that while the entire galaxy may know that Earth has life, because of the oxygen in our atmosphere. They don't know that Homo sapiens exists. And this is an argument you can throw at people who say, you know, I'm being visited and occasionally abducted, right? Because why are they here now? Right? They don't know we're here. By the way, 1/3 of America believes that we are being visited, so presumably 1/3 of you do as well. We can talk about that after the talk, right? Okay. So that's one way they might be getting in touch, but I don't think it's applicable. Maybe they're just broadcasting to everybody in the galaxy, right? You know, subscribe to our blog site or whatever, right? Well, the trouble with that is it takes a lot of power if you want to cover the entire galaxy. Here's a number, 10 to the 17 watts. That's a lot of power. It's more than you're going to get from these solar cells out here. 10 to the 17 watts is more than all the solar energy, in fact, falling on the planet, right? So that's a big PG&E bill if you want to have a transmitter that broadcasts to the entire galaxy simultaneously. You have to be somewhat more selective. Okay, so I don't think that they're doing that, although who's to say, you know, maybe power bills are not a concern to ET. The other possibility is that they're doing what I talked about earlier in this presentation, namely, they have found planets that are known to have life by sniffing their atmospheres. And maybe they've got long, long lists of these worlds. I mean, who's to say, but they might. If they do, then they're going to target those guys. And maybe their scheme would be this. They would say, look, I'll just send each one of these planets that I know has life, I'll send them a 1-second ping maybe every 2 days. Right? Maybe they got 500,000 or 1 million of these things. So they just ping each one of these sequentially with a little mirror and a PC. Right? And if you saw that flash in the sky once every 2 days, you would say, you know, there's something special about that, Bill. And you would spend a lot of time looking in that direction with a much more sensitive setup to find the omnidirectional broadcast that would back it up. So in other words, that suggests that you might be, what you want to do is have a SETI strategy where you look for very short pulses, you know, every couple of hours, every couple of days, who knows what the interval is. And if you find those, then you go back and you look with your radio telescopes for the very faint signal that might be being broadcast to the entire galaxy to save their power bills. We don't do this. I think it's a good strategy, but we haven't done it so far. The other possibilities, we might be able to synchronize our transmitting and our listening. This is just to give you an idea of the flavor of this. Suppose that dish up at the top, those are the Klingons, right? And at some point, maybe a supernova goes off in the galaxy. Bam! All right, so all the Klingon telescopes are looking at that supernova, of course. But then one of the Klingons gets kind of clever, and he thinks, well, you know, he waits a half a day till his planet is rotated 180 degrees, and then he broadcasts in the anti-supernova direction, you know, hey, look, we got a whole lot full of used cars here with air-conditioned, reconditioned, air-conditioned, and you might want to, you know, buy one. Now, here's Earth, and at some point, we see this supernova in the sky, and every telescope in the world is aimed at that supernova. And sure enough, you know, 12 or 15 hours later, we get this message, hi, you may want to be interested in buying one of our used cars, or whatever it is, right? Okay, so this kind of a scheme, by synchronizing up to some galactic event, tells you where to look, when to look. We don't do this, but it's a good idea. The trouble is there aren't that many supernovae in our galaxy. This is another way to do it. This is just the way the Earth would look from, you know, some distance away when it gets in front of the sun. This is just called a transit. But this is also another good clock. This is an event that the aliens might know about, some of them anyhow. And they might send a signal to reach us just as we're transiting the sun, because that's, you know, that's the part of the clock everybody will agree is special, right? So the advantage of that is they wouldn't need very much power, actually, if they just aimed at the entire sun because they don't know where the Earth is. It would only take 30 watts, and they could send a signal we could pick up. If they actually knew where the Earth was, they could do it with a transmitter whose power is the same as a laser pointer, right? So this makes sense, and it's very simple to do. It means all we have to do is look in the anti-sun direction all year, just scanning the ecliptic. We don't do this either, right? The reason we don't do all these things, by the way, is not because we're stupid, although, you know, that might apply. But the real point is that there's no money, right? SETI is privately funded in the US, and there's, you know, we just depend on checks that people send us. So there isn't enough money to do these sorts of things. But a lot of them are quite simple and don't sound too stupid. The other way to do it is the brute force march of technology, and this we are doing. This is up at Hat Creek, which is about a 5.5, 6 hour drive from where you're sitting. You go up to Redding, and that's always exciting. You go up to Redding, and you make a right turn, and you go into the Cascade Mountains for about 1.25 hours, and you'll get to a place called Hat Creek. And there we're building, eventually, 350 of these antennas. Each of them is about 20 feet across. It's called the Allen Telescope Array, because Paul Allen, you've heard of Paul Allen. Paul Allen has given the SETI Institute enough money to get this started, get the first 40 antennas built. So this is quite an interesting instrument because it can be used 24/7 for this kind of search. It'll enormously speed up the search. In fact, this is what it'll look like eventually. This was an animation, but we don't have that file on this computer here. But in any case, with 350 antennas spread across the desert. You can go up there. You can go up there this afternoon. Well, it'll be dark by the time you get there. But you can go up there tomorrow. Go up there this weekend, and they'll be happy to show you around, right? You can just walk around. You can kick there are no tires, but you can kick the metal pylons of this thing. That's what it looks like from the air. This is a photo I made about 6 months ago. So you see a couple of the antennas set up there. Now, the important point is this. My mom, for example, will occasionally call me up and she'll say, you know, you guys have been doing this for a long time. She doesn't phrase it that way, but she'll say, Seth, when are you going to get a real job? And I have to explain to my mom, I don't even want a real job, but, you know, yeah, who would want one? But the facts are that it sounds like this is just an endless task, that this might take, you know, centuries or millennia before you've looked at enough stars to have any decent chance of finding a signal. But that's wrong. And here's why. What I just plotted here was just some index, some metric of the speed of these searches as a function of time. All right, and you can see they're getting faster, and those of you who paid attention notice that this is a semi-log plot, right? So they're getting faster exponentially, and in fact, they just follow Moore's law. Now, this is not, you know, in obeyance to the local tradition, everything follows Moore's law. It's because, of course, SETI is basically digital electronics. That's what it really is, in terms of the speed, anyhow. So it's just following Moore's law. It's doubling in speed on average every 18 months. Okay, and that'll be true for this new Allen Telescope Array, too, at least for the first 15, 20 years. So I just worked it out. I mean, this is always dangerous, but I worked out how far out into the galaxy we will have looked at every star with this new array, assuming we got it built by the year, I don't know, 2008 or something like that, okay? And you can see, of course, we look farther and farther out. But the important point here are these numbers here. These are people's guesses as to how many societies, how many civilizations are out there in the galaxy that are broadcasting right now. How many societies are sending radio waves through your bodies as you sit here, right? And we don't know the answer to that, but here are some guesses. Carl Sagan, he figured there were 1 million. Carl Sagan was kind of an optimistic sort of guy. If he's right, we'll hit one of them by 2014, right? Isaac Asimov figured 670,000. Isaac Asimov was a very smart guy, and he could estimate this to 2 decimal places. I don't know how. Okay. Frank Drake, who works at the SETI Institute, of course, and started this whole field, he figures 10,000. Right? And now, even if you take Frank's conservative estimate, you see that it still pays off in the next 24 years. Now, the thing is, if you ask Frank, and I've asked Frank, where'd you get this number, 10,000? And Frank will say something like, well, you know, driving over on Highway 17 this morning, and I put my finger out the window, and I figured 10,000, right? Nobody knows. The bottom line is these are all guesses. But these are guesses made by people who suggest that SETI is worthwhile. So if you take the entire range of guesses, even the most conservative of these, well, it means that this is not going to take centuries. If it's going to pan out, if it's going to pay off at all, it's going to do so within the next 24 years. And that's why I'm always willing to bet anybody in the audience a cup of Starbucks, of course you get them free, but a cup of Starbucks that in the next 24 years we'll find ET. So either we find ET, which will give you something to talk about at your next cocktail party, or you get a cup of coffee. All right. Let me just, very briefly, people always ask, what would EP be like? We don't know, of course, but fortunately Hollywood does. If you think about it, there are only 2 kinds of aliens as far as Hollywood is concerned. They're like cowboys, right? They're the white hats and the black hats. And there are only 2 kinds of aliens. They're either the good ones or the bad ones. There aren't too many good ones like little ET here. Aren't too many good ones because they don't make such interesting storylines, but nonetheless. Now, you know, little ET comes all the way from the Andromeda galaxy. That's, what, 2 million light years? Just to pick some plants and play with the kids. You can tell that he's a good alien because he's got those big blue eyes and the short nose and the wrinkly forehead. He looks like a kid, right? He can also drink beer, even though he doesn't have the same amino acids in his biochem. I don't know. All right, that's a good alien. These are, here's some more good. Anybody recognize this? This is Close Encounters of the Third Kind, right? So here are some more aliens that have come to give Richard Dreyfuss a joyride in their spacecraft. And again, you can tell these are good aliens because they look like kids. They've come 800 light years or who knows what to do this, and they forgot to get dressed at the last minute, but that happens at none of the parties I go to. Okay. then there, then there are the bad aliens. There are a lot more bad aliens than good ones, like these guys who are, you know, just come here to trash the planet. When you think about what the bad aliens like to do, by the way, there are only a couple of things that they do like to do. Either trash the planet and kill everybody, or abduct us for breeding experiments that probably wouldn't work. Okay. Now, when you think about it, those are exactly the things that you have been fearing now for 200,000 years at the hands of your fellow humans, right? You know, 100,000 years ago, you're sitting there in some valley, and you're worried about some tribe on the other side of the hill that might come into your valley and take all your land, depriving you of your food supply, or take all your women and deprive you of your inheritance, okay? So that we figure the aliens have the same things on their minds. It doesn't make any sense, but there you go. Okay, here, anybody know what film this is? Nobody's old enough. Yeah, this is the '54 version of War of the Worlds, which I think was slightly better. But in any case, they moved the venue here to Los Angeles, so here are the Martians destroying LA. But of course, those of us here in Northern California figure LA had it coming. More bad aliens. This is kind of your ISO standard alien these days, right? I mean, all these gray guys with the big eyeballs. And all this is a projection of what we think we are going to become. Right? Because, you know, we're losing our hair, well, right? We're losing our olfactory sense, our dentition. These guys have small noses, small mouths. But they do have big eyes, because in the future, all of us will be sitting around designing websites. So that's all that is. I mean, it doesn't mean the alien, you know, the aliens aren't going to look like, that's terribly anthropomorphic, actually. Oh, a message. Okay. Do I dare click it? No, I don't dare click it. Okay. What happened? I did click. Help. Is the owner of this computer still here, or did he go back to work? Anybody here know anything about computers, actually? Yeah, Windows. This is not your fault, I know. Let's try another one. Okay, that's great. Do you need a job? Okay. Yeah, this is what we always assume about the aliens. They're kind of like us, right? There are billions of them living on this planet, and you know, they maybe have lifetimes of 100 years or 1,000 years or whatever. And so they're kind of like us. We always assume this, right, in fiction, because we don't know any better. But it might be wrong. I mean, this is our definition of intelligence, right? You guys all have 3-pound brains. I don't know how many of you weighed your brains this morning. They're about 3 pounds. They take on the order of 25 watts. Which means that your CPU, if you want to call that, takes about 1/3 of all the energy you consume. So when you go to In-N-Out Burger, you get a burger. You know, 1/3 of all those calories are going just to keep your brain warm, whether you're playing solitaire or doing something useful. But, you know, 1/3, it's very expensive metabolically to have a big brain. And as you'll note, when you look at the other animals in the zoo, very few of them do. So this is expensive. Now, this is a plot. They say every time you show a plot, you lose 10% of the audience. So I have 12 of these. This is just a plot of how big your brain has been, you know, for the last couple of million years, right? Here, 3 million years ago, your brain was half a kilo, so it's like 1 pound, right? And 1 million years ago, your brain was 2 pounds, and now your brain is 3 pounds, right? Now, it took 1 million years to go from 2 pounds to 3 pounds, but it was probably worth the trouble, because if you have a 2-pound brain, you're a forest ape. If you have a 3-pound brain, you get a job here, okay? And I don't know, you probably don't hire too many forest apes, so there you go. It's worth, and you might figure on this basis that, doggone it, maybe E.T. has just gone up this curve a little bit farther, and maybe they have 5-pound brains or 10-pound brains. Maybe we will have 5-pound brains or 10-pound brains. Neanderthals did have slightly bigger brains, but they weren't 10 pounds. We probably won't go to 5-pound brains. I mean, women are having trouble giving birth to kids as big as they are now. They will go on strike. There's also the fact that your head gets, you know, as your head gets bigger, you need, you know, you've got a mechanical problem. Actually, you look around, I mean, how big all our necks are with just 3-pound brains. If you had a 5 or 10-pound brain, you know, you're sitting there in your car coming down 101, you turn your head to watch the guy who's passing you, and you'll twist your head off, which will be disconcerting to the people in the back seat. So maybe this is what happens. Maybe E.T. will just have big brains. It'll be a big brain version of us. But it seems that that's less likely than that we'll simply re-engineer our own biology. This has become kind of a common story these days, although it wasn't 5 or 10 years ago. And that is, we're only here to get the machines going. okay? Because the fundamental point about the machines is that they evolve much more quickly. This is the kind of intelligence we have today, a whole bunch of neurons. This is what we're talking about in the future. Here you see, yes, Gary Kasparov having a bad day, right? You remember in 1997, he takes on IBM's Deep Blue, and he wins. But then the engineers at IBM go back, and I think they stripped the software down. The software actually got simpler, but they had more processing power. Came back with, I don't know what they called it, Deep Blue Special Edition or something, and Kasparov loses, right? Now, the funny thing about all this is not that a machine can beat Kasparov at chess. The funny thing is that Kasparov said at the time that it was as if the machine had a kind of alien intelligence. Right? It was just a game-playing machine. And yet, to him, it came across as something that was clever, which suggests that maybe you really could make a thinking machine. Now, this is Kasparov's chess rating as a function of time. And you see it went up for a while. I don't know where this first point is. I think 3 months, or I don't know what he but you can see he got better at it for a while. But then he just sort of stopped getting really much better at it. I mean, it's incremental improvement, right? That's human intelligence. Well, this is Hans Moravec, Carnegie Mellon in Pittsburgh, and what he's plotted here, you've probably seen this plot. What he's plotted here is the amount of compute power you can buy per $1,000 as a function of time. So from 1900 on, you notice this is exponential. This plot runs out at about 1997. In 1997, $1,000 buys you the compute power of a spider. Okay, if you're an arachnophile, that may interest you. If you just extrapolate to 2007, clearly $1,000 will buy you the compute power of a lizard, which, I don't know, might be marginally more interesting. But the real point is this. By 2020, your desktop computer will have the compute power of you, right? And a lot more memory. So at that point, I don't know what happens. I, for one, intend to just turn the keyboard around. You type, whatever. So obviously, it doesn't mean that they will be smart. We know that because, I mean, you need the right software. And you could say, we will never be able to make a machine that can actually think. A machine that could, teach English literature at Stanford or write the great American novel or do physics or things like that. We assume that's true. And yet, if you ask these people, could you make an artificial kidney? Yeah. Could you make an artificial heart? Yeah. What about an artificial one of those things that fits between your ears? No. And I think that that's whistling in the dark. You may not. The jury's out on this. But if you can do it, the point is that the improvement curve is one of these Moore's law kinds of curves. The time scale for improving machine intelligence is extraordinarily short. And within one human lifetime, you have one machine that's better than all the humans put together. Okay? So my point is only this, that the real ET may not be a little soft, squishy gray guy or soft and squishy at all. There's so many advantages to machine intelligence that I think you can rule this out. I don't think that's what you're likely to hear. I think it's far more likely that you're going to hear something quite different, and that it's machine intelligence that is really what rules the universe, and biological intelligence is just a very short step to get it going. This may sound a bit discouraging to you, and if it does, I recommend you adopt a hedonistic lifestyle and enjoy it now. I'm sure many of you already have. Okay, well, finally, suppose we hear something. What happens? Now, most people, you meet them in the bars of Mountain View, not that there are any, but if you were to do that, and, they'll ask you, so if you guys find a signal, what happens? They already know the answer to that. Some guys from inside the Beltway will come to Mountain View and shut us down, right? Why? Because you couldn't handle the news. Now, this is bizarre because 1/3 of you believe that the aliens are already here, buzzing the countryside and occasionally abducting your sister for experiments that are inappropriate on a first date, okay? And yet you're not rioting in the streets about that. So if you picked up the Merck News tomorrow and it said, scientists find a signal coming from a nearby star system, would you say, well, that's it, Marge. I'm not going to work today. I'm just going to riot in the streets? You might. But I doubt it. I doubt you do that. What actually happens is that there's always this bottle of champagne in the fridge at the observatory. I have to say, every time we go to the observatory, it's a different bottle of champagne. So it's I've noticed that, but yeah. This is actually a picture I made now 10 years ago. This was in the summer of 1997. This is when we were over on Landings Drive, just across the street from you. We used to be neighbors here. Occasionally would come over for lunch, but then you were called Silicon Graphics, right? But yeah, this is our building over there in Landings Drive, and we had picked up a signal that for 16 hours looked like the real deal. This picture was made at 3 in the morning. You can see people just sitting around. But nobody would leave. Everybody was glued to the monitors waiting for this star system to rise. We thought we'd found it. And I was very nervous. I could not sit down. I was going around taking pictures. I could not sit down because I thought, this is going to ruin my whole week. Okay. Now, the interesting thing was at 9 in the morning, nobody had called, by the way, from the government. No guys with narrow ties had showed up. Even the mayor of Mountain View, whom I knew personally at that time, didn't bother to call up. Nobody cared. Yeah, oh, you disappointed? Except Bill Broad, one of the science writers from the New York Times, did call at 9 o'clock, and he said, well, Seth, what about that signal you're following? My first thought was, how do you even know? But it didn't matter. And I said, well, look, you know, we've gotten lots of signals before. They've always turned out to be interference. I'll call you back in 3 hours. He said, OK. 3 hours later, we figured out what this was. This is the SOHO research satellite, a European satellite. Once again, it's always the Europeans. This European satellite, and it was, you know, the signal from it was bouncing around the steel work of the antenna and getting into our receivers. So false alarm, called the New York Times, and they said, OK, fine, that was it. But if this really happened, you see, it would take us a week to figure out whether it was real or not. And all that time, while the New York Times might be waiting for us to confirm it, the Weekly World News will not, right? So if we actually find ET, you will read about it first in the checkout line at Albertsons. That's my conclusion. I've already read it. You've already read it. Yes. OK. Will we understand anything? You know, we were able to figure out the hieroglyphics, but these were written, as it turns out, contrary to what, again, you might hear at late night radio. These were actually written by humans. They were called Egyptians. Okay, and in fact, this is not such a dead language. There's still people who could speak this in AD 400 or so. Figuring this out took Champollion about, what, 30 years or something. But he had the, even less actually, but he had the advantage of, you know, for example, the Rosetta Stone that helped. We won't have any of that. So I think that the bottom line is that we might figure out what they're saying if they're making it easy for us. But I think that the chances of ever understanding what's being transmitted to us are rather slim. I think it would be like giving the output of one of your computer modems to a Neanderthal, right? The Neanderthals weren't that stupid, the gentleman already pointed out, but they will never get it. They don't have the context to ever get it, right? And I think that that'll be the case. We will get all these bits, everybody will download them onto their hard drives, people will try to be like Champollion and figure them out, and after 300 years of trying and failing, maybe they'll start worshiping these bits. I mean, I don't know what's gonna happen. And then you could say, well, okay, we got the message, but we never figured it out. Maybe you guys never should have bothered with this. Well, I don't know about that. This is the frontispiece of a book by Robert Hughes, actually. He was a New York Times art critic. But in any case, he wrote this book about Australia. And this is a woodcut from the early 19th century showing Captain Cook landing in Botany Bay down there in Australia. And the locals, as you can see, have a welcoming party. Happy to see him. Now, the point is that, as Hughes wrote, for 40,000 years, there had been a watch glass, a crystal of isolation sitting on top of Australia. And when Cook sailed into Botany Bay that morning in 1770, that watch crystal broke. That watch glass shattered, and there was no putting it back together. And what I'm trying to tell you here today is that I think in the next 24 years, you're going to see the watch glass of isolation that has sat on this planet for 4.5 billion years shatter as well. OK, thanks very much. Okay, I know you guys are in the real world, so you have real work to do, but if you have a couple of quick questions, I'll be happy to answer them.
So the estimate of about 10,000 civilizations that we could detect is based on what sort of lifetime of a civilization, when we're in that technological phase where we can actually communicate.
Yeah, the question is, the 10,000 estimate from Frank Drake is based on how long, I mean, what is the implied lifetime of a technological society? And this is really a reference to what's called the Drake equation, where L is the last term. And Frank Drake just thinks that all those terms before L multiply to 1. In other words, he figures the average lifetime of a technological society is 10,000 years. So far, we've had maybe 50 or 100 years. So maybe this is good news. But it's a guess. Yeah?
I read somewhere a while ago, early on in the SETI program, there were some candidate signals that were received but could never be explained to terrestrial sources.
Yeah. Yeah, the question is, early on in the SETI program, there were lots of signals that were found, but never repeated. What happened to those? What were they? It's true. Back in the old days, what you would do is you'd go to the telescopes and you had these big computer tapes, you know, recording the data, and then you would take them back home, and you'd play them back, and you would always find signals. We pick up signals at the rate of 1 every few seconds. Okay. You find these signals, but you're no longer at the telescope. So you can't verify them until the next time you go back, and you never found them a second time. It could be you really had picked up ET, but ET went on summer vacation, right? When you went back, they weren't there. I mean, that could be. But that's not science. If you can't find the signal over and over again, it's not there. And I have to say that ever since we developed the capability to follow up on the signals within minutes, which is what we do now, there are no signals that go funny. There are no mysterious signals anymore. So I think those are probably all terrestrial interference. I think that's a fairly safe bet. One more? Yeah.
So if there was another civilization about as noisy as us, how far away could it be and we could still detect it?
Yeah, how far away could we detect Earth with the kind of equipment that we use for SETI? Yeah, well, I mean, it's, you know, this equipment is not optimal, but even if you were at the distance of the nearest star, Alpha Centauri, you would have a hard time. With our equipment, you couldn't find anything except the military radars. You could find those. They're maybe not so interesting to listen to, but those you could find. You could find our TV signals if you built, you can work this number out, a couple of thousand acres of rooftop Yagis. You know, the neighbors would complain, but with that sort of thing, you could pick up the carriers from our TV. Yeah. Okay, oh, one last.
Are you looking for sort of, so I guess the follow-up question is, what kind of signals, what's the scenario that they would be transmitting? Is this an accidental transmission
Yeah.
like radar, or is it intentional?
Yeah. Yeah, the question is, are we listening for leakage radiation, just stuff that accidentally leaks off their planet like our TV does, or deliberate transmissions aimed our way? And the answer is, obviously, we don't know. Look, we've had radio for 100 years. Right? If you'd asked Marconi 100 years ago, so what do you think your invention will be used for in the year 2007? I'm sure he would have had a lot of ideas, and they all would have been wrong. Okay, so to extrapolate what a society that may have had radio for 100,000 years is doing, right? Pinging nearby stars might be a high school science fair project. I mean, you don't really know. And in a sense, we don't even care whether it's deliberately sent our way or we just pick up by accident something that leaked out of their solar system. We don't care. At the moment, it seems more likely that you have a much better chance if they're deliberately sending a signal our way. That's the assumption. Okay, two things. One, obviously, we're next door to you guys. We're like a mile and a half away. Okay, so if any of you are interested in this, you know how to find me. My name is Seth. I'm the only guy with that name. It's almost SETI, actually. So, you know, call me up. And the second thing is I'll be here for another couple of minutes if you have any other questions. Thanks for your attention.